Imagine holding the world's most powerful supercomputer in your hand. That's exactly what happens every time you unlock your smartphone. But here's what nobody tells you. Every tiny computer chip begins with ordinary sand pulled straight from the earth. Think about this. Billions of electronic switches fit inside a chip smaller than your fingernail, working together every single second. And this is where it gets truly extraordinary. Engineers build these invisible structures with almost unbelievable precision. A single speck of household dust can destroy an advanced processor worth thousands of dollars before it's even finished. That's why the world's most advanced chip factories stay cleaner than hospital operating rooms. Every hour of every day, the air flows so perfectly that invisible particles never get the chance to settle on exposed silicon. Most people never think about this, yet thousands of manufacturing steps hide inside every tiny processor you own. Each polished silicon wafer carries hundreds of chips, and every one follows exactly the same incredible manufacturing journey. Some factories spend more than $20 billion building a single semiconductor fabrication plant before producing just one chip. Inside those walls, machines measure features only a few billionths of a meter across, beyond what human eyes can ever see. What happens next surprised even experienced engineers. The journey begins with one of Earth's simplest natural materials. Our journey starts deep inside quartz mines, where nearly pure silicon dioxide hides inside massive white rock formations beneath the Earth. Most semiconductor-grade quartz comes from carefully selected deposits in the United States, Norway, Brazil, and China. Gigantic crushers smash solid quartz into smaller pieces before workers remove unwanted minerals that could ruin future computer chips. Even tiny traces of iron, aluminum, or calcium can create microscopic defects inside tomorrow's advanced processors. The clean quartz travels hundreds or even thousands of miles to specialized refining plants by rail, truck, and cargo ship. Now the heat becomes almost unimaginable. Electric arc furnaces reach nearly 2,000 degrees Celsius, around 3,600 Fahrenheit. Inside the furnace, carbon strips oxygen away from silicon dioxide, leaving behind molten metallurgical-grade silicon nearly 98% pure. That sounds impressive, yet 98% purity isn't remotely clean enough for the world's fastest computer chips. Scientists must push purity beyond 99.9999999%, removing nearly every unwanted atom. Most people never realize engineers count contamination in parts per billion, sometimes even parts per trillion, during purification. Purified silicon transforms into special gases before engineers grow gigantic single crystals with breathtaking atomic perfection. But growing a flawless crystal is only the beginning. Next comes one of manufacturing's greatest precision challenges. That flawless silicon crystal now enters a factory where every movement matters, and one mistake can destroy months of work. Diamond-coated wire saws slice the crystal into wafers just 775 microns thick, moving with astonishing precision. Each cut takes several minutes while cooling continuously removes heat, preventing tiny cracks invisible to the human eye. Next, polishing machines remove microscopic imperfections until every wafer reflects light, like a perfect mirror across its entire surface. Now comes the heart of chip manufacturing, a process called photolithography that prints invisible circuits using powerful ultraviolet light. Inside the scanner, mirrors polish smoother than glass direct extreme ultraviolet light with incredible nanometer-level accuracy. The wafer moves only a few millimeters each second, while thousands of microscopic patterns appear layer by layer. Chemical developers dissolve exposed photoresist, revealing transistor patterns so tiny they disappear beneath ordinary microscopes. Powerful plasma etching removes exposed silicon, using energized gases reaching temperatures above 10,000 degrees Celsius inside microscopic arcs. Engineers repeat these coating, exposing, developing, and etching steps more than 100 times for advanced processors. What you're seeing forms billions of transistors, each switching electricity on and off billions of times every second. And the most astonishing challenge still lies ahead, because even perfect-looking chips can secretly hide invisible defects. At first glance, every chip looks perfect, but the real inspection begins where human eyes can no longer help. AI-powered vision systems compare every microscopic pattern against digital blueprints, searching for defects measured in just a few nanometers. High-speed scanners capture thousands of images every second, creating detailed maps of billions of transistor connections across every wafer. Even a defect smaller than 30 nanometers can reduce performance or completely destroy a processor before it reaches your device. Most advanced factories achieve defect rates below 1%, yet every rejected chip represents hours of lost manufacturing time. Robotic handlers move wafers without touching them directly, using vacuum systems that protect every delicate microscopic structure. Laser measurement systems verify dimensions with accuracy measured in billionths of a meter, far beyond ordinary manufacturing standards. Next, automated probes test every completed chip, sending millions of electrical signals through microscopic circuits in just seconds. Some processors enter thermal chambers cycling between -40 and 125 degrees Celsius to prove long-term reliability. And here's something remarkable. Experienced engineers still catch rare problems that even advanced artificial intelligence occasionally misses. Human experience and machine precision together create processors trusted in spacecraft, medical equipment data centers, and billions of everyday devices. But how many chips does the world actually build every year? The answer is far bigger than almost anyone imagines. Every year, the semiconductor industry produces trillions of individual chips, powering nearly every electronic device on Earth. The global semiconductor market now generates well over $700 billion annually, making it one of history's largest industries. Taiwan leads advanced chip manufacturing, followed by South Korea, the United States, China, and Japan in global production capacity. Together, millions of skilled workers, engineers, researchers, and technicians keep this extraordinary global supply chain operating every single day. 50 years ago, a chip held only thousands of transistors. Today, advanced processors contain more than 100 billion. Did you know one advanced chip can contain wiring stretching for several kilometers if every microscopic connection unfolds into one line? Did you know the mirrors inside extreme ultraviolet machines rank among the smoothest objects humans have ever manufactured? Did you know building a modern semiconductor factory can take more than 5 years before producing commercial chips? Researchers already develop 2-nanometer technologies, while scientists explore entirely new materials beyond traditional silicon for future generations. Artificial intelligence, autonomous vehicles, quantum computing, and space exploration will demand even more powerful chips during the next decade. And after everything you witnessed, the ordinary computer chip in your pocket should never look ordinary again. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering, built with precision beyond anything our eyes can see. Every message you send, every movie you watch, and every discovery you make begins with engineering like this. Behind every breakthrough stands countless engineers, scientists, technicians, and factory workers whose names most people will never know. The next revolution in artificial intelligence, medicine, transportation, and space exploration will start with even smaller computer chips. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.